Hello friends, welcome to my next video tutorial of seismic design of 10 storied steel structure using structure program. In this video tutorial I am going to show you how to design this 10 storied building as per my this AutoCAD file. You can see here I have this is beam and column layout plan. Also there is architectural plan which is tentative and also an tentative elevation here. My first floor height is 4 meter, then the rest of is 3.6 meter. So I am going to show you how to do a complete structural design with seismic forces of this project. To start this project, open Structure program, new project, next, yes, finish. From this right side just close this box window, write here 0 in this first cell, and now you can see a node has been drawn here. From here take this node cursor, select this one and go to the plan. I have drawn this column point, so I am just drawing point for each column. So here this point has been drawn. Now I have to go to down here, and in the lower side I have 1 2 3 4 another 4 column. So select this one, go to here this transitional repeat, and I am going Z direction. This is 6 meter, number of step is 4, then click OK. Now you can see I have 1 2 3 4 total 1 2 3 4 bay. And now select all this node, go to here this transitional repeat, and I am going to here along X direction now, and I have in this direction 1 2 3 4 5 6 7 8 and total 9. So along X spacing is 5 meter, total 9. Okay, drawn. And here as you see here I have in this portion I have some other column, 2 column. So I am going to here, so here I have this one, select this one and Ctrl C from the keyboard, then Ctrl V from the keyboard, go to X along this is 2.5 meter. Okay, and now copy this 3 to above at approximately 2.4 meter, then Ctrl C, Ctrl V from the keyboard, go minus 2.4. okay, now select all these nodes and go to your geometry, then connect beam along X first. Okay, now go to again geometry, connect beam along Z axis. Okay, now you can see as per my this beam layout plan all the red color beam has been drawn here. If I consider the line as a beam and the node are the column, from here select this view from Z and take this beam cursor from this left side list, select everything this way, and I have my first floor is 4 meter height. Go to here transitional repeat, select Y from here, I have 4 meter, and check this link steps, then press OK. Now delete all the bottom beam. Okay, done. Now click here this display whole structure. Now you can see the one story building has been drawn. Okay, and now save this model, going to your file, save as, save at your convenience place in your computer, give a name here, save. Okay, now I have to draw here my sub beam. This is the blue color beam is my sub beam, and I have 1 2 3 4 5 span. Select this beam and this way select all this beam, and I'm just showing you some. Now go to here insert node, add node, this is 4. Okay, now double click on any piece of the beam, and now you can set 1.2 meter is the distance. And now take this node cursor from here, go to top view, and from here select this way, then go to here geometry, connect beam along X. Okay, select all this the same way, geometry, connect beam X. The same way break all this other beam and draw the sub beam. The same way I have drawn all the sub beam, and going to here this isometric view, you can see I have made my model of first floor. And now I have to draw my bracing here. As per I have bracing here, here and here. To draw bracing, I can just draw by taking from here add beam, pick this point, this point, this point, this point. I have here this point, this point, this point, this point, and I have here. Okay, same I draw here. Okay, my drawing of bracing is also done, and now I have to define for various member size, and I am using here build up section. If you want to use hot roll section, you can use from here in the list and go to here general from this left side, and now you will see a window here which is the properties window. From here, if you use hot roll section, then you have to go to a section database, and from here you can check lots of code available and lots of size available. From here pick size and then use them, but I am using build up section, that's why I have to go to here define, then tapered, and I have various size. I am defining my interior column size as 550 and thickness of the web say 0.1 10 mm. Then depth at the end of the node is 0.55, the same depth, and width of the flange say 0.45, then thickness of the flange say 0.16 mm. So 10 mm, I can say this is 12 mm, and the width of the bottom place and the thickness of the bottom place you don't need to add, it will take this 2 value of top. So I am not using this 2 value here, so this 2 value will be counted automatically. Now click add. So this is my interior column. Just you have to assume some size first, then you have to finalize later after imposing all the load. Okay, next I am using this size for my side column. Say this is 12, add. Next I am using for my corner column which is say 8 mm, and this is a 10 mm, add. Now I have main beam. In this short direction I have main beam here. This is my main beam, so the main beam size will be say 500, 500, 8, 10, this is 200, then add. And I have also main beam in the opposite direction like this here, so this beam size will be say 350, 350, 6, this is 15, this is 08, 8 mm, 6 mm, add. And the lastly I have the sub beam. The sub beam say 5 mm, then this is 6 mm, 300, 300, 150, then add. Okay, close. Now I have to define for my bracing size, so I am using here bracing size as tube, and this will be hot roll. Go to here section database, and from here going to BTC, I am just using here tube say 150, found here find from this list 156.3, 150, 156 mm, select this one, then add, close. Okay, and now first, now go to here select, then beam parallel to Y, right click, new view. Okay, and go to here this top view. From the keyboard press shift then K to display the nodes here, and now select this first which is my interior column size. So take this beam cursor and drag your mouse this way to select all the interior column. To check that, go to here this isometric view. Now you can see all the column which are in interior side is selected. Now check this assign to selected beams, assign, yes, select this one. The next one, go to here top view again, select this way, hold down the control key, select this way, this way, this way. Go to here this isometric view again to check. Okay, assign, yes, select this third one, select this column, this 4 corner column. Go to here isometric view, assign. Okay, so my column size has been assigned. Now go to here, this icon, symbol and labels, structure, full sections, apply, OK, check. Now you can see all my column are along this direction. The orientation of column has been changed as per my drawing. I have all this column vertically oriented. So to rotate this column, I have to assign beta angle here. From here, go to here, beta angle, create new angle, 90, OK. Now select this beta angle, select all this column, assign, yes. Now you can check all the column has been rotated 90 degree. Now this is as per my drawing. OK. Now click here, display whole structure. Go to here, this view from Z, select all this beam, right click, new view. OK. Go to here, this top view, and select my fourth one is my main beam. So I have to select here this way, press Ctrl, drag your mouse this way, this way, this way, select this one, this one, this one, here, here, this one, then assign, yes. And the next one is my main beam at the opposite direction. I have to select this one, then here, last at the bottom I have here, and next is here. OK. Now assign, yes. Now go to this display whole structure, and now you can check if all the beam has been assigned. OK, all the beam has been assigned. Now select this last one, which is for my sub beam, and before that select this tube and select all this, press right arrow couple times and hold down the Ctrl key, select all these bracings. OK. Now assign, OK. Now select this sub beam size, the sixth one, and go to here, select, then missing attribute, missing properties, and now assign, yes. OK. So there is no beam is missing about properties. If I go to here, this icon, full section, apply, OK. Now you can check here if there is any member have no size, or by going to here, select missing attribute, missing properties, there is no member which has missing properties. So I have all the size available now in my plan, and I have to check here, use my this fifth beam for my this one, and this one, assign, OK. OK, done. So my size definition is done. Now I have to draw slab here. I have deck slab here, so steel deck, then concrete. I have total 125 mm slab, and I am just assuming a average 100 mm concrete slab thickness. From here, go to thickness and define point 1 add, close. Now from here, take this cursor, add new noded plate, add. From here, take this, add 4 noded plate, this icon, and from here you have to click 4 point. First this point at the corner of each column, so this point and this point, this point. Now take this cursor, which is plate cursor. If you click here, you will see there is a surface, and going to here 3D rendered view, you can see there is a slab. Actually there is a slab surface drawn here. I have to assign thickness from here, so select, take this plate cursor, select this one, and when plate thickness is selected and assign to selected plates, assign, yes. And now you can see there is a slab, and the same way you have to draw slab by taking this, add 4 noded plate, pick this point, this point, this point, this point. So the surface has been drawn. You have to draw this way all the panel, and then you have to select this panel, then you have to assign this slab thickness. OK. So do this same thing for all these panels. OK, I have drawn the slab for my all panels. If you go to here, 3D rendered view, now you can check I have only opening at this stair and also at these 2 lip points. So I have already drawn the slab for all my panels. So you have to draw that using the same technique. And now After drawing slab, go to here this Staad editor, from here this icon, write here density, enter. Now here is the density, then change this density to 1e minus 32, which is I am just neglecting the slab weight. I will assign load for this slab weight, and I have given here this slab due to increase the stiffness of the whole structure, but I am not counting the weight here. I will count the weight as a load. So save this one, close, done. Now go to here this view from Z. Now I have to make more story. I have only one story right now, and the project is total 10 story. To do more story, I have this floor height 4 meter. Select everything this way, go to here transitional repeat, then Y, assign a right here 4, default step spacing is 4, the number of step just 1. Okay, now take this node cursor, select all the node from the top level, right click, move, right click, move, then move minus 0.4. so I have 3.6 meter total height, and I have right now 4 meters, so I am just reducing the size by 0.4 meter. Yes, okay, now check the height is now 3.6 meter. Okay, now again select the above floor, everything this way, make sure you have selected everything of the above floor. Now go to here this transitional repeat, Y, this is 3.6, and the step will be another 8, then okay. Now you can see this is a 10-story building. Now I have 1 2 3 4 5 6 7 8 9 10. Okay, now select this top floor, right click, new view, yes, this 3D view, and here I have this stair. I have to draw my stair room above this. To do, I have to select this way here, and also I have machine room, select this and go to here the same way, transitional repeat, Y, 2.4 meter, link steps. Okay, delete this unnecessary column here, delete. Okay, delete. So my stair room has been drawn. Same way I have also machine room here above this stair, select all this, then transitional repeat, Y, this will be 1.5 meter above the slab level, link step. Okay, same way delete this additional column from here. Okay, done. So if you have any more story above this level, you have to draw, and you have to assign for size here. I have first this column is for my this one, yes, third one is for my this column and this column, yes, fourth one is for this one, yes, and I have also this second column for this two, yes, and number 2 for this interior column 2. Okay, now if I go to here display whole structure, go to here this icon, structure, full section, apply. Okay, now you can check again, go to here full section, apply. Okay, now you can check the structure has been drawn completely. The only problem is the column I have drawn above has not been rotated, all are in other directions. So I have to go to here general, beta, this angle, select, and select the other column of this label, select from here. Okay, assign, yes. Now if you check, going to here this icon, full section, apply. Okay, now you can see all the column is as per the drawing direction. Go to here general, then support, and from here create a support. Here I have pin type support, select pin, add, select this one and take node cursor, select all the node at the top level, bottom level, and select all the nodes at the bottom level, and select this support, assign to selected nodes, assign, yes. So I have assigned the support now. So my model creation is done. Now I have to also copy. If you go to here this 3D render view, you can see I have only slab at this lower level, no slab at the top level, so I have to copy the slab from lower level to upper level. Why there is no slab? Because we have selected everything using this beam cursor, so beam cursor does not select the surface, so I have to select plate using this plate cursor, select all this plate, then go to here transitional repeat Y. I have everything at 3.6 meter apart, total step 9, okay, and now check going to here this 3D rendered view, so all the level I have the slab, and similar way I have to draw slab at this top level too. If I want to draw slab at this top level, take this beam cursor, select this way, right click, new view, okay, go to this top view, from here select all these beam in this direction and go to your geometry, then merge selected beam, merge, okay, select these two beam, same way geometry, merge. Now take this add 4 noded plate, draw plate, also here I have plate. Now it was open in the below level, but here there will be slab, and go to here general, from here select this plate thickness and take this cursor, from plate cursor select this surface, control this surface, assign yes, okay. So my whole model creation is done. Now I have to go for the next step, and in the next step, okay, next step I have to release moment for my sub beam. Go to here this, or just take this beam cursor and from this top level select any one of the beam, double click on that and go to here this change releases at start. From here click this partial moment release, from here MPZ, this is 0.99, so I am assuming 99% moment release here because this is my shear type connection, there will be no moment at that end. So add, go to this next one, at end, same way check partial moment release, MPZ 0.99, add, now close. Now if you see this beam has two circle at this two end, so similar way I have to do that for all my sub beams. To do that I have to go to here specs, from here this one, select this one and going to here select by specification property name, from here I have this 7th beam as my sub beam, then close. When this is selected, from here check assign to selected beams, assign yes, click this second one, same way assign yes. So all my sub beam is now moment release at each end, and same way I have to define this bracing as truss member because we don't have any moment here. In this bracing we have only tension or compression. To do that, click here this beam, from here select truss, click here add, select this member truss, similarly go to here select by specification properties name, select this a tube 150156, then close this window, now assign yes. So almost everything is done for my this model. Now I have to go for gravity load assigning. So to assign gravity load, go to here from this left side list load and definition, select this second one load case details, add, and from here define load cases, and first time defining earthquake loads because ETAPS program need to assign earthquake load first. If you define any other code it will show you an error, so I am defining that, so earthquake first. So EX plus first, I have earthquake load from 4 side of this building, so I will define EX plus, add, then EX minus, add, then EZ plus, add, then EZ minus, add. Now I have DL which is dead load, then LL live load, add, close. Select this dead load, first add this cell point 1, add, close, select this cell point and from here click assign to view, assign, okay. So cell point is now counting. Now I have to assign here dead loads, and here I have available load for my this building. I have live load of 5 kN per meter square. Then dead load I have for slab weight is for 100 mm thick slab. I have 2.4 kN per meter square. Floor finish 1.25 and minimum partition wall 1.25 kN per meter square. Then total dead load is 3.65. Total live load is 6.25. And I have a 125 masonry wall load on the beam along the perimeter of the building, which is 125 mm thick masonry wall with a height of 3.15. I have deducted 1.45 meter for my beam depth, and then 223 is the unit weight of the masonry. So I have to assign here 9 kN per meter load. So go to here, first dead load, add from here floor load. I have total dead load of 3.65, so minus 3.65, and take this node cursor, click at the top node of the building. I have total Y 38.8, so the range is 0 to 38.8. Then add, close. Now if you click on this load, now you can see the load is showing here. Similar way, go to here live load, select this one, add, then floor load. I have total live load of 6.25, so this should be minus 6.25, and this is also 38.8. then add, close. Now if you click here on this load, you can see the load is displaying here. The blue line is the load line. And now select the dead load again, add. I have member load here, click here member load. This force is minus 9 kN per meter. This is along GY, add, close. Now select this load, and from here go to this view from Z, take beam cursor, select all this beam this way, select this beam, and now go to here, select beam parallel to X first, then select beam parallel to Z first, then right click, then new view. Okay, now go to this top view and select this load, and now selecting beam this way, hold down the control key and select this way, also select this way, also select this way. Now assign to selected beams, click here assign, yes. And I have also load here, select this beam, I have load here too, then assign to selected beams, assign, yes. And now if you check, if you go to here this whole model, display whole model, now you can check the load. Okay, my gravity load assigning is completed, and I am ending my this video here. And in the next video, the second part of my this tutorial series, I am going to show you how to assign lateral load, which is earthquake load, and wind load, then how to analyze it, and finally design this model. So thanks for watching my this video. Hope to see you in the next video.